Hello everyone, welcome to my YouTube channel Concept here. In today's class, we will discuss about Elgamal digital signature in the subject of cryptography network security. In last class, we seen about what is digital signature. Okay, in general terms, what is the meaning of digital signature means? It is nothing but it is a watermark of the user identity. General చెప్పుకోవాలనుకుంటే. Okay, in same as what is the Elgamal digital signature means? It is one of the digital signature scheme. It is one of the digital signature scheme. Here we'll use two keys. First one is public key for encryption and private key for decryption. It is a asymmetric key cryptography. We can say it is a asymmetric key cryptography. Why? Because we are using two keys for encryption and decryption. So it is the asymmetric key cryptography. Here, what is the working procedure? The working procedure will contain several steps. We will see one by one. So the first step is select a prime number. We are mentioning the prime number q. We are taking the prime number as a q. The second step is select a primitive root of alpha of q. Okay, whatever the prime number are taking as a q. For that q, we have to take a alpha primitive root. Okay, the condition is alpha less than q always. Okay, generate a random integer xa. Xa is nothing but we will use xa as the private key in future. Okay, here generate a random number integer xa. What is the condition here? The xa is 1 less than xa less than or equals to q minus 1. You have to follow this condition. You have to select a xa. And next, fourth step is calculate ya. What is the formula for ya is alpha x power a mod q. This is the formula for calculation of ya. Okay, and next step is we have to generate the public key and private key. Okay, so here I am writing here generate the keys for user a. Private key and public key. What is the private key here? xa is the private key and public key is the formula is q comma alpha comma ya. So we also got private key and public key. Next step is in order to sign a plain text message, user a will perform hash function. Okay, user has to perform a hash function. So what is the user has to perform a hash function on message? So m equals to hash function of m. Okay, here m is nothing but message equals to hash function of m. So here what is the condition here? 0 less than m less than q minus 1. Next step is generate a random key integer k. Next we have to take a random integer k. Here this is the condition, and here we have to calculate the GCD of the k comma q minus 1, that should be 1. Okay, now after this one we have to calculate s1 value and s2 value. What are the formulas for s1 and s2? S1 formula is s1 equals to alpha power k mod q, and if you write like this, the k inverse mod q minus 1. So, and what is s2 formula? S2 formula is s2 equals to k inverse m minus xa xa s1 mod q minus 1. These are the s1 and s2. These are the two formulas we have to remember for exam. Okay, next what is the next step? Next step is now we got a signature pair s1 comma s2. Okay, this is the sender side. Okay, these are the steps will be performed at sender side. Okay, when you are sending sender a message, he will apply these all the steps for creating the Elgamal digital signature. After that, he will send the message to the receiver side. Okay, and what is the receiver side? Receiver side, actually we won't check if you get any message from some person. We won't apply any methods to check it is a original message or not. Okay, here also the B side, if you want to verify, okay, generally we won't verify, but if you want to verify, we have to verify the message came from original message or not. So how to verify? We have to calculate v1 value and v2 value. We have to compare these two. If both are same, that is valid. If both are not same, that is not a valid signature. So here v1 is the formula is v1 is alpha power m mod q is the v1 formula, and v2 formula is ya whole power s1 whole power 2 s2 mod q. These are the two formulas. I have to calculate v1 value and v2 value. If v1 equals to v2, then signature is valid. If the v1 is not equals to, then signature is corrupted and signature is came from unknown person. Okay, now we will see one example for this implementation. So here I am taking example value q equals to 19. Q is what is a q? Q is a large prime number 19, and the second step is we have to take primitive value of q. What is the primitive value of q is alpha. So I am taking here alpha is 10. Okay. If you have to calculate, and if you in the exam purpose, if you remember these values, okay, q equals to 19 and alpha equals to 10. Okay, now what is the start step? Random integer we have to calculate xa. Xa equals to, what is the formula? 1 less than xa less than q minus 1. Okay, according to this, xa is I am taking as a 16. I am getting as a 16. 16 means what? 1 less than xa, q minus 1, 18. So if you are implementing this, xa equals to 16. Okay, next one is we have to calculate ya. What is the ya formula? Ya equals to, what is the formula here? Ya equals to alpha power xa mod q. So I am implementing here ya equals to alpha power mod a. So if you are implementing this, 10 power 16 mod 19. If you are calculating this one, we are getting y equals to 4. Okay, in next step we have to generate the keys. What is the keys formula here? Key equals to keys. Private key is xa. What is xa is 16. Public key is q alpha ya. So this is the public key. Now we have to generate hash code hash code of the message m. So m equals to h of m. What is the, for example, I am taking here message equals to 14. The message plain text message is 14. So I am taking here 14. Okay. Next we have generated the a k value, k integer value k. So how to calculate this? Again we have the conditions. I have to implement this one. So we are getting k equals to 5. Okay, I am taking here k equals to 5. Next we have to calculate the s1 value. That is the formula for alpha power k mod q 10 power 5 mod 19. If we are calculating this one, we are getting 9 s1 equals to 3. That is the first one s1. And what is the s2 value? In s2 value we have to formula this one. If we are implementing use the derivation of the formula, finally we are getting k inverse is 11. If we are implementing the same in s2, we are getting s2 is equal to 4. Now this is the sender side. So we are generating the signature of the page s1 and s2. Okay, now at the receiver side, what I told, if you want we can check, if you want only you can check. Okay, how to check? We have to calculate the v1 value formula, v2 value. If you calculate the v1 equals 16, v2 equals to 16. Now what is the step? Now v1 equals to v2, so the signature is valid. If the v1 equals to not, v1 is not equals to v2, then the signature is invalid. Okay, this is about the Elgamal digital signature. If you have any doubts, please ask me in the comment section. What is Elgamal cryptography means? So Elgamal signature means it is also asymmetric digital signature. It uses for two keys for encryption as well as the decryption for the public key and the private key. It follows us some several steps. Up to have the 8 or 9 steps, we have to follow these methods. These steps in the user side and sender side we have to only receiver side we have to only 2 steps. We have to calculate the v1 and v2. If you have to validate these two, then if it are both are same, then it is a valid signature. Otherwise it is not a valid signature. Okay, thank you everyone. Please subscribe our YouTube channel.
నా ఛానల్ పేరు గుర్తుందిగా, ప్లీజ్ లైక్ షేర్ అండ్ సబ్స్క్రైబ్.